This is the AQA June 2013 Statistics 1 unit. Question 1. So we've got a question about maximum monthly temperatures in Fahrenheit. Part AI, calculate to one decimal place the mean and standard deviation of the 12 values. And we want the maximum monthly temperature here. We're just going to use our calculator to do this. We're going to put the data into our calculator and let it do the calculations for us. So we're going to click on mode, number 3 for statistics, and then we're going to choose number 1. We're going to enter our data, so we've got a maximum monthly temperature, so we want the first row of that table, so 39, 40, so we're just pressing equals to enter the data into our calculator, 48, 61, 71, 81, 85, 83, 77, 67, 54, and then 41. I'm just going to check that we've got 12 data in there. Press AC to get out of that, and then we can do our calculation. So Shift and 1 for the stat menu. I'm going to choose 4 because we want something about the variance. So number 2 for X bar. X bar is our mean. So the mean of our data we've got is 62.25. So just put that up here, X bar. And it asks to give our answer to one decimal place. So that's going to be 62.3. And we need to check our units. So we've got degrees Fahrenheit. And then if we go back to our calculator, we can get our standard deviation. So again, menu 4, and we're going to choose SX because we've got a sample here. So number 4, SX, and that's 17.5 to one decimal place. I'm just going to write it as 17.5. And I've got my units there again. Part 2, we're saying that we want to convert from degrees Fahrenheit to degrees Celsius. And we've given a formula for that there. And we want to use this formula in our answer from part AI to calculate the mean and standard deviation in degrees centigrade or Celsius. So we need to think about linear scaling. So firstly, with the mean, what's going to happen to my mean? Well, I need to take away the 32 and then I need to multiply by 5 over 9. So I'll just do that. So we're using our value of 62.3 that we had up here. So 62.3, take away 32, and then we're going to multiply that by 5 over 9. So 16.8 is our new standard deviation. Mean, sorry. And now we're in degrees centigrade. For the standard deviation, when we scale it, if I'm taking away 32 from each of the values, I'm not going to change how spread out the data are, so I don't need to worry about the 32. That's not going to make a difference to standard deviation. So the standard deviation, I just need to do standard deviation multiplied by 5 over 9. Because when I multiply it, I am going to change how spread out the data are. So go back to our calculator. So standard deviation was 17.5, and I'm multiplying that by 5 over 9. So my answer should be 9.7. I'm just giving that to one decimal place. Part B, the value of the product moment correlation coefficient. It's between the values of U and V is 0.997 to 3 decimal places. So it's asking us to give a reason and give the corresponding value where x and y are now in degrees centigrade. Okay, so if I'm just changing the units from Fahrenheit to centigrade or Celsius, that's not actually going to change the correlation between the two sets of data. So actually, the correlation is just going to be the same, 0.997. So we're calling that R, X, Y, they're my new variables. And so we're just saying that correlation is not going to be affected by the linear scale. I just need to make sure that I do actually write down the value of Rxy, the dot moment correlation coefficient there. I need to make sure I give that value of 0.997.